All right, section 3.4 for geometry is about finding and using slopes, which should be relatively familiar to you. If you've taken Algebra 2 as well as Algebra 1, it should be even more familiar to you. You should do numbers 1 through 3, 10, 11, 12, 17, and 18. And this is really very much about recording carefully. So most of us are familiar with the term slope. We commonly refer to rise over run. Well, how do I find the rise? It's the difference in the y values. How do I find the run? It's the difference in the x values. So if I'm given 2 points on a line, I don't need to graph them, but I think it's nice to think about where they are. So -4, 2 is somewhere over here, and 3, -5 is somewhere over here. So my line kind of looks something like this. What is that slope? So as I said, it's best to label your points. Students, whenever they make an error, or often when they make an error, I come over and it's because they haven't labeled their points and they haven't written things carefully. So I'm going to find the slope, and I'm going to take y2. Be careful, it's a -5, and I'm going to subtract y1. It's a 2. And then I'm going to take x2. If I went in this direction, I need to go in this direction again. 3 minus a -4. And I get -7 over 7, which is -1. And just so you can see, suppose I called this point x1, this point 1, and this point 2. Well, if I had done it in reverse, if I had done 2 minus a -5, 2 minus a -5, then I would have to do -4 minus 3, and in this case I'd get 7 over -7, which again would be -1. So as long as you are consistent about what you subtract from what, it shouldn't matter which you call point 1 and which you call point 2. Sometimes there's a special circumstance that arises. What's going on here is, notice my x values are different, but my y values are the same. x1, y1, x2, y2. So what does this look like? It looks like -2, 3, and then 6, 3. What do I have? I have a horizontal line whose y value is not changing. So that equation is y equals some number. In this case, it's y equals 3. It's sort of counterintuitive that y equals something is a horizontal line, but notice that y is always 3, and that's what happens. What does the slope look like? Well, if I do y2 minus y1, I get 3 minus 3 over 6 minus -2, which is 0 divided by 8. What does that equal to? That is equal to 0. So a horizontal line is y equals some constant, and slope is 0. What's going on here? Well, now what value isn't changing? X value isn't changing. So I have 2, -1, and I have 2, 5, and I get a vertical line, and x is some constant. In this case, x equals 2. Actually, I'll try to be consistent. X is some constant. In this case, x equals 2. What's the slope going to be? 5 minus a -1 over 2 minus 2, and we can't divide by 0. We say that is undefined. So vertical line has x equals some constant, slope is undefined. Please do not say no slope. I don't know what that means, no slope. Does this have no slope, or does that have no slope? This has a slope of 0. This has a slope that is undefined. That is the only thing that counts. What else might happen? Well, if I'm asked, are the lines parallel? Well, just calculate the slopes and see if they're the same. I'm asked, are the lines perpendicular? Well, again, calculate the slopes, and they should be negative reciprocals. For example, if the slope is 6, the perpendicular slope should be -1 over 6. If the slope is 2/3, the perpendicular slope should be -3/2. Therefore, if you multiply a slope and its perpendicular, you will get -1. Notice that 2/3 times -3/2 is -1. And finally, the other kind of problem you're going to have to do is graph lines that are parallel and perpendicular through a point. Well, here's our line L. It contains points A and B. And I want a line parallel to it that goes through P. Well, how do I find a line parallel? Well, it's going to have a slope of 6 minus 0 over 7 minus 3, which is 6 over 4, which is 3 over 2. So if I go over 2, I need to go up 3, and there's my parallel line. Now the perpendicular will have a slope of -2/3, so down 2 over 3. There's my perpendicular line. So these lines are perpendicular, these lines are parallel. That should take care of section 3.4.